Hello, hello. How's everybody doing? Man, I think I said this last time too, but it still feels weird just hitting the button and going right away. Um, I think I gotta put a little fade in or something just to settle my brain a little bit. But third stream this week, and we'll do a fourth tomorrow. We're knocking a whole bunch of streams in our switch to YouTube here. The thing that we're working on accomplishing is moving a bunch of our integrations and stream overlay stuff over from what we were using, that some of which was very Twitch specific or just straight up only worked with Twitch, over into things that will work with YouTube. And one of those things that we've been working on integrating is the text chat. If we start up our server here, I can, oh yeah, we don't have it on there. We're gonna put the text chat over here, which is kind of why this is a little offset. So I feel weird just being offset a little bit, but we're gonna have a chat over there, so that's gonna be the reason. And we've made some progress. What's complicated about it is we have a scene done in WebGL. So all of our interactions through chat and events and such happen in WebGL. And we're throwing our chat into the same scene, which will be fun because our WebGL scene has physics hooked up. And that can make for some interesting interactions. But that starts to complicate things because getting text dynamically into WebGL is not terribly straightforward, and we're using a HTML layer in WebGL. And what's happening is it's doing some React portal stuff and syncing up and using Matrix 3D transforms to get that text chat to line up with our WebGL element. So if we have a box and our text chat is right on top of it, they should move together. And we'll see that when we switch over to this. Let's go ahead and I guess we'll turn this off and on to get it to, yeah. So like this, the text sticks. And if we open up the scene, let's go to the chat, I think, and we'll just worry about the chat route. We also got to enable all that. Let's get this sized properly here. Yeah, that's pretty good. So you can see it's actually like attached to it. And right now we have some transforms locked, so they will stack and will not like tip off. But if we turn that off, and we did this yesterday, they'll actually like fall and crunch, and the text sticks with it. That's not gonna work for a text chat though. Yeah, I can't really read that. So that's, I think, what we're gonna work on today. I think the big thing is going to be the layout of the text and the styling of that WebGL element. I think that's what we'll focus on today. And then as part of that layout, I think we might end up trying to rely on the physics engine to do or help us with the layout. So right now this is like a stack of elements, and the physics interaction is what's holding them stacked. If we removed like that interaction, the collision between these elements, there's what, 11 of them up? Yeah, 11 of them up there. If we removed that interaction, then they would all just fall straight down. So we got the bottom one actually fixed right now, and all of the other ones are dynamic, which we can see. Let's make this just a little bit bigger. We do that right here. So basically the last element in that array, we're fixing it. So the way we have the ordering, we're doing a reverse. So as they come in, it'll be the oldest message is going to be at the bottom. You can see it's going to cut out my finger there. There's a number 1, a couple lines above my tip of my finger there. That element is the one that's fixed. So everything is sitting on top of it. So I think we'll play around with the physics a little bit and like dial in this layout. Still milking a little bit of a cough here, which is not great, but you know, what can you do? It's like that, the weather changes in Wisconsin and like everybody gets colds and gets that just crud kind of sickness, and it's really stuck around a lot this year. The people that get it end up having it for like weeks, which is kind of a bummer. So we were looking at this one as well last time, which has some, you know what, not now that I look at it. Oh, I guess we do want to use effect because we're having it be dependent on the drop, and the drop is the thing that's resetting it. But we're using this structure as a way to understand how the text reflowing works. So I saved it. If we reset this, we should only have 1. Yep. And it is definitely too high. That's going to be another thing. We're going to be determining the position of the first one. So it might make sense to like reset this. So we're gonna focus on one element here. Text is a little bit bigger, so it is going to definitely reflow, as in it's gonna like pop outside of the box. And what we were just looking at as far as code goes, we have pulled, using that as an example, pulled out and worked on this and made this happen yesterday. And what this is doing is it's actually scaling that WebGL box so that we can have the initial size just be 1, and we'll scale it up to fit the size of the text. And I mean, we've got a little bit of like rough numbers in here. This X box size is sort of a guess. We could actually probably put a little bit more depth on these. We're actually going to reset this to 0. And this, it would be nice to make this a little bit more dynamic rather than us having to just straight up guess on how those numbers are supposed to come out. Okay, so it's showing up right in the middle. It would be nice to get it a little more dynamic, but you know, it is what it is right now. Did it actually? That text doesn't look like it has been resized properly. Maybe it's fine. It's just a weird zoom kind of thing. So what we need to, like, the box itself seems big enough. So I think we've got that at least reasonably dialed in, enough that we can set it aside and come back to it later and refine it later if need be. But we definitely need to deal with that text. So we got to figure out, and we were working on this a little bit the other day. We've got a transform in there, which is hard-coded. So this is the sort of HTML element container that matches the canvas, as I understand it. That's what this is trying to achieve. And then from there, it does a transform, translating the transform, doing a couple translations, one of which is Z, and Z 540 pixels. Z, I wonder if that's like the zoom. CSS, no, MDN, CSS, translate Z. Okay, so it is the depth. And that, I believe, is to help it match up with the element itself. Because the camera is further back. When we deal with the HTML, it's technically like at the position of the camera, but if we want to have that text look like it's attached to an element, we need to, in this case, translate it back to that element. Matrix 3D is going to do a lot of the rotational type of things, and then translate. That's the one that sort of, I'm not sure how it calculates that. So 960 and 540, it looks like it's just half. So it's doing like a translation to like that just doesn't make sense to me. 960 pixels. It could have something to do with if we adjust this. Let's adjust this down. Let's see if this moves. 960 and 540. Just so we can kind of understand exactly what's happening there. I don't think it's actually going to move because that value that we are changing doesn't actually adjust anything there. Yeah. So I'm not sure how that's figured out. All we're setting is transform is true. So we're not actually adjusting the position or anything right now. If we would adjust the position, also, I don't know if that's in units. That could very well be in units. Units being like the WebGL units. I'm going to just take this out. I don't think that's right, and I don't think I want to keep it anyways. But let's go ahead and adjust the position and see what that looks like. Most of what React 3 Fiber is doing is it is building on top of and sort of acting like a superset of 3JS. So there ends up being a fair amount of inheritance in which we have HTML, and this has a bunch of its own properties, its own special properties, but it's actually inheriting from, and that might actually not be right. It's inheriting from other things that are defined. Yeah, we get some React forward ref stuff in here. But there's like primitive elements and then more, I guess, refined elements, you would say, that are building on top of the primitive elements. So there's sort of an inheritance where this primitive element has position as a property on that object that you can adjust. And then everything else that's building on top of Object 3D also has that same property. That being said, it makes it a little bit difficult to just look at the docs, and because all of those layers of inheritance aren't shown. So if you look at the docs for 3JS, and I guess in some ways to React 3 Fiber, you only see like what special things are implemented for that item that you're looking at. It has a note. At the very least, it does have a note that says, hey, it's inheriting from here. But you ended up having to like click through layers to like figure out from this object that I'm looking at, what are all the methods and properties and such that are listed on it. And I feel like that ends up leading it to a situation where, as I'm working with this, it feels like there's sort of a certain level of familiarity that really ends up being beneficial. Like I know position is on here and that I can adjust the position, but that wouldn't be immediately obvious unless you sort of knew all that inheritance and dived into it. Okay, so what we did is we changed the position. We want to see if that position has changed anything. So we changed it on the HTML. I don't think it actually changes anything there. Because this is just straight up an HTML element. It is moved down. Down and over, right? Maybe a little bit. Well, let's remove that location adjustment there. I mean, maybe. Position relative. I don't see any actual style or CSS here that would indicate that our position argument is having an effect on anything. So where'd that go? Here, position. So we're gonna actually go ahead and remove this. And let's see if it does actually seems like it's changing something. So this is what it looks like if we do a refresh. It is actually changing something. Interesting. So if I feel like this is probably good. I'm gonna actually remove the transform here. And the reason I think this is probably fine is we have a set width and it's sort of dependent on a lot of things. Because the WebGL is in a 3D space and this is based on your camera view into that 3D space. So if anything really changes in that 3D space, including the camera, I think that's going to goof that number up. In which case, it might actually make sense to set the style here. But we'll think about that. We'll keep that in mind. So this position seems to be adjusting it up and over. And we did remove that transform. Okay. So what are we working with now? Before we dig into that too much, what we have adjusted is the position. Now, is there going to be anything else that we have adjusted? We adjust the position here of the box. Box X location is adjusting that. I think some of this is already sort of like programmed into this HTML element because it's expected to stick with and target this. So if we adjust the position here, I think this is more like a global position, and any change we do here, it's more like a local position of that HTML element on the WebGL element. That's my guess. I'm not 100% on that. Do we have anything else that's just in the position? We have message class, and we don't have any classes here. So No, I don't think we have. I think we just have that one position arg now. So if we look here, now is this adjusting the, do we still have that on? Yeah, we have that on. I don't think we actually need to adjust. Actually, we might want to set this to be the box. Box Z, because we want, as I understand, and we were kind of looking into this yesterday, the origin of the box. So we have this box, but it's actually a cube, so there's depth. In the bottom corner of it, the bottom left corner, I think is the origin. And when we do an extrude, we do an extrude out. And towards the camera in our case is a positive number. So the text right now, I think, is actually shown on the back side of the box. This really, really thin box is shown on the back side of it. We actually want to show it on the front. So I think we can use this to basically put it on the front of the box. Let's remove these, and we're going to change one at a time now that we know that they're actually doing something. And what are we looking at? So we have this adjustment here. I feel like this is sort of misleading. I don't know that we're going to be able to, like, unless we look at the code. That is an option. We could go look at the code and see if we have anything there that's going to help us. So we don't have any adjustments here right now. And I'm going to guess that if we have a piece of HTML, the HTML is a specific height. I think the center of that is right at the bottom of, well, and there's scaling in there too. So we set this to be 1 pixel. But the computed, I guess the computed right there is nearly 1. Really? Really? No. Did we accidentally just step into it? I think, like, I want to say that is just because it's in the first position. If we add in a second element, what is this going to look like? I wonder if the position that it sets defaults to the center. And by setting the position to 0, 0, whatever, Z is not something we care about right now. X and Y, if we set those to 0, 0, we basically like overriding the default. And that's why it's not working. There are 2 elements that happen to sort of be right on top of each other, which is no bueno. And they are, well, at least, well, one of them is fixed. Interesting. So we're going to reset this to see what it looks like here. That's pretty good. So there's a little bit of depth to these things. I don't know if we'll be able to. I don't know why. Like at some point, like WebGL, or at least this, maybe it's just my scene specifically, but like at some point it just like prevents you from zooming in anymore. So you can see there's a little bit of a thickness there that is beveled, and we will end up being able to see a little bit of thickness, especially if we make these things just a little bit thicker. But as it is right now, the rounded box with our mesh that we have is not serving us well as far as being able to see those edges. So let's go ahead and change that real quick. And that I think is going to I think that's going to give us a little bit more. We can use a matte cap. I think that's going to give us a little bit more indication on like where the edges of this shape are. So we can do different materials. I think I'm fine with this material for the moment. We might want to make it dynamic per message, so we're gonna put it in the chat box itself. So each message can theoretically have a different material, but we're gonna start just with this default one that I have set for this. And we are gonna swap out our mesh basic material for a matte cap. And are there any dependencies that we need to bring in? So we need to use matte cap texture. And I think that might be the only thing that we need to worry about. And I think this is starting to show how useful this React 3 dry is. There's so many little helpers and stuff in here. It works really well. Texts. My parents got new phones and text support. Yep. Okay. So we got a texture. We're gonna stick with this texture for the moment. And I did a size of a texture. We can go there and we can grab other IDs. But this I think should be enough to give us the new texture. And we don't have any lighting either, I believe. Ambient. Actually, I bet it's this directional light that's just like putting a deep shadow in there. Oh. So we have this, and there's built-in geometry to it. This is sort of a lower level asset, so we don't actually have any of the lighting features and such in here. But here we've got a couple extra things in this. I'm actually just gonna grab all those. I suspect we'll probably just want those. And we might end up having to... What is with this texture? I'm not getting an error or anything, no. Let's try a different texture. As far as this matte cap thing goes, we can either give an ID of a specific one, or I think we can do a number. Come on, you're not going to come out now. I hid the other line for you. So our ID can be a string or a number. The string is an actual like specific ID, and they also have them numbered. which is fun for the text type things, because somebody could just say, it's a lot easier to say, you know, use material number 5 than it is to say use that. Like, that's a little bit harder to remember. Why is it rounded box? It seems like it is specifically with this WebGL thing. I don't see anything in here that would be affecting that. Let's try 7. This should be changing as well. So if... Oh, there we go. Something wonky with that texture, maybe. Here, let's bump it over here, or update it here. That's fun. So can we can kind of see a little bit of those edges now. I'm gonna have to refresh. I lost it. Trying to get to that edge. Whoa, look at that. Oh, a little bit too much. So sort of like a translucent type color. And we do have 2 layers there, and it does look like that HTML is projected on the front of it now. So we might actually be able to turn on occlusion and see how that's working. We gotta get all these docs open for all the libraries we're using here. We were digging into this a whole bunch last time. There is a property in here called occlude, or can be true or ref. True occludes the entire scene. Yeah, I think we want to say occlude is true, and that will, if it's gonna work how I'm expecting it to, when we have a box that falls behind another box, we shouldn't see that text. We should be able to only see sort of one layer of text here. And it's a little bit hard to see here. Can we, this one was falling through, right? Now they're sitting on top of each other. Let's drop a whole bunch of them in here. I think we're gonna get some weird physics things, but that's fine. That was great. I kind of want to see what it looks like here. I didn't do the same thing. Okay. So we've got everything locked in as far as like translation and stuff goes. So we're gonna have to turn that off for it to get it to like fall and tip onto each other. We are fine with rotations being turned on, so that will let them tip. That's kind of hilarious. But see, I don't know, that's gonna be hard to see, I think. We can only see one set of text, so I think it's actually working. We can still see the text. Let's see what it looks like over here. Yeah. So we're gonna also have to deal with that. We want the rotations on. Stuff is bouncing around now. I don't think we have an actual floor or anything in here. Let's hammer or let's get this material dialed in, and we'll go from there. So this is the list. The whole main page has a colors, so all the images. So I'm feeling like we should pick something that I kind of feel like I want to go a little bit metallic, just because that's not typical CSS, and I think it'll make it more obvious that, like, hey, this has got something fancy going on here. But I also want to fit with sort of the color theme that we've got going on right now. Like this one might be a good one. Page 9. The last one on page 9. Oh, of course, I don't. Page 9. Whoa, that one's kind of wicked. So we can also copy these, and actually, now that we're here and looking at it, this might make sense to do rather than doing this. String, please. We're gonna remove this and that. So now if we go here, they are a different texture. Kind of don't mind that look. Let's move this up just a little bit. The starting position. We'll go with 5 because I want to be able to actually see it over here, because this is where we're going to be looking at it. We're going to go just a smidge taller. There. So no, 10 and 9 like flip-flopped there. I feel like that was a previous save. Does it blink when I'm like turning this on and off? I can't tell if that's just the preview refreshing, because I'm like looking at the OBS preview to see what it looks like. There we go. That's not awful. It doesn't track it amazingly. There is a little bit of a hitch, but we can play around with that. This I kind of dig the metallic. I don't know if it's actually going to show through and what it's actually going to end up looking like, because I think we'll end up getting sort of the whatever we're seeing in the middle, which I don't mind. I definitely don't mind that. So let's go ahead and set this and give that a refresh. That doesn't look bad. We're going to need to change the text color. And this like clash of like they're overlapping. We're gonna need to deal with that. I'm kind of okay with that texture. Let's poke at the physics stuff for a little bit here. And see if we can't hammer down that just a little bit. We are using React 3 Rapier, and it's a little bit of a newer library. kind of mentioned this last time, and we've done a handful of streams on it now, and or dealing with it. Dealing feels negative. I've enjoyed working with it. It seems like a very cool library. It's just new. You know, things are gonna work perfect because it's new. It's just sort of how it is. The thing that we care about though is adjusting the physics. So we can do contact force events, sensors, attractors. I'm assuming attractor is... So we can have an element be an attractor. And in the same way, we can set a negative value to do the opposite and have these things act a little bit like magnets. Standard attractor and attractor. So is this... I don't know if an attractor is like an additional specific thing. Let's look at this. Give it a second to load and we're going to go back here. So this might be like one way we can kind of go about handling it. We don't want these things to overlap, so we want to adjust that. We've also got some sort of high level things. We can pause the simulation. I'm not sure what the priority would do for us. Okay, so attractor is just it's just wrapping one of these. So I think we can try this attractor real quick. Then from there, what do we do? I think within WebGL, we might end up having to look at the React3 Fiber docs. They have ways that we can, so we've got this physical element. We, based on the size and like, I'm assuming some sort of like default mass density ratio type thing, it's giving that element physical properties. But we can override it, or I think we can adjust some of those values. So like we can say that this little square is more like a piece of lead. You know, it's real dense, real heavy. So even though it's this big, it's actually heavier than it looks. As you know, like a feather would be the opposite of it. These attractors are more... They feel more like magnets, I guess, where you have some sort of outside force besides specifically. I mean, they say it simulates a source of gravity. I mean, that's kind of what it is. I'm sure that's how it's programmed. But it feels to me like a better metaphor would be more like a magnet, because that element has mass, in which case it has gravity, and maybe they've just completely skipped the whole gravity situation, other than the top level thing that you can set for just like a directional gravity. So maybe the like gravity between elements is effectively nil, which in most simulations that's not unrealistic to do, because the Earth has enough mass to have gravity. Or the Earth has enough mass to have a gravity which is noticeable relative to us, because me as a person, my gravity, my mass is much, much smaller than the Earth. So that difference is what causes me to basically like stand on top of the Earth rather than, I guess, the opposite of that. So in that case, if you got two, so like if I cloned myself and there was two of me standing next to each other, we're technically asserting gravity like on each other. There's a force, but it's so small that in your calculations it's easy enough to just ignore it. With magnets it's a little bit different because it's like a whole different what's the word I'm looking for? It's a whole separate physical property. And this seems to be more in line of what is representative of what a magnet is doing. So, standard attractor, like this is what we want. I'm not sure what a whole bunch of attractors next to each other are going to do. But let's go ahead and see. Tractor. The range is probably fine. I don't know what the position is going to do. I'm assuming that's adjusting the position of the center of mass, which I do not want to do. And then I'm presuming going to have to import it here. Tractor. Now what does this end up giving us? Now things might get kind of wonky here. I have no idea what's going to happen. Oh. It seems actually that makes sense. That seemed unfamiliar, like I hadn't run across that before. I think we are going to have to update React 3 Rapier, which might end up meaning that we need to do a bunch of extra upgrades. Ooh, we got some upgrading to do. I'm gonna assume that the latest of this is going to be fine. These tend to be pretty compatible here. The React Spring might end up giving us a little bit more troubles. 46.7. I don't know that I actually want to update that. Yeah, we'll leave that one. We still do have theater in here from when we were playing around with that. We might be able to just straight up take that out right now. But we will leave it as is. Let's do an install and then we'll get this up and running again. And then this header should go away. Okay, npm run start. I have an alias that if I do nr, it's aliased to npm run. So we get a little bit of extra stuff going on here. And I could probably update V too. I think V went to a new version as well. But, you know, let's just not update too many things at a time. Okay, we can't see anything. Just to make sure that we don't have anything else going on. Because this only happened when we put the tractors in. Let's take those out for a moment. I don't know why you need to think about that prettier. Okay. So that's not a... Okay. So it's definitely something with the tractor. We still do get a little bit of that like bounce and like squish that's happening there. Let's turn the tractor back on. And what does it look like as far as this goes? Yeah, what is happening? Is it actually rendering it? Let's check that first. Yeah, so like, what's a little bit, I mean, I'm gonna say frustrating, but I don't know if that's the right word. A little bit frustrating. The workflow that I tend to use is looking at the element tree, but you can't really see that with the canvas. And I haven't like broke out of that expectation yet, so I need to like figure out a better workflow or a different workflow to deal with canvas. But in this case, we have a canvas plus layers of HTML elements on top. And if something's going way wonky, I don't actually get any HTML elements, and I don't end up seeing any HTML elements there. So like that ends up being a pretty clear indicator that something is going on there. So we've got a static. Gravity means the same force is applied on all rigid bodies within range. Okay. I thought you could wrap a rigid body. Can we not? Was I just reading that wrong? No, so there is actually a different... So we may actually not want to do this. Because I was thinking that we could wrap it. But it isn't really like a wrap element type of situation. It's a whole like separate element. Are we, let's see, range, strength. Some yeeted holy. And I think part of that is like, there's these fixed attractors maybe? Yeah, so in this case, like it's a central point. Can we do first collision groups? You can also assign interaction groups. So like if we group this, what does that end up looking like? And this might actually end up screwing up some of our other little integrations that we've had to cobble together. But let's just test it and see. I mean, it's just like yeets some stuff. It's hard to really know what's happening there though. Which is part of why we've got the debug component imported, but not actually used anywhere, because this should toggle on. Okay, so we've got an attractor just centered right in the middle of the screen. And I'm guessing there's a whole handful of them now because we've created one per thing. So the question ends up being, okay, so we can set the position. So if we set the position to be the same as our rounded box, what does that end up looking like? And see, like, we're gonna get some weird interactions in here because like each one of these is trying to repel. I want to see if it shows up over here. Oh, we're actually gonna get a whole bunch of like, yeah. It didn't go too wild there. I don't think attractors are gonna be the thing that I was hoping it would be. At least I don't think it's gonna solve the use case I was hoping it would. So let's go ahead and remove it. We're going to comment out the debug because we don't want that on right now. So that being said, other options. we can look at React 3 Fiber, because that's sort of the lowest level integration, I guess you could say. Let's reset this. This is too much. And that's where it's going to start getting into the properties of each of those elements. Well, meshes. We'll say meshes is probably the best word for it. Except it does not have. So freeing resources. So this frees resources for us, which I think is probably good. Render defaults, create root. What is this? Custom. We can render to a root. So this would let us remove React DOM. If we don't end up needing this, we could potentially swap this. And like that might be fine. So we might actually want to consider that. But the thing that you're doing is shaving off size. I don't think we care about that. Because it's just for this, and we're specifically like we turn on the stream and it's just theoretically loaded once. That's not going to make a big difference. User interaction. Okay, where do they have? Where do they have that? And I'm quite certain that they had some documents explaining basic animations, loading models, events, and interactions. So like these are all the interactions we can do. So we could do a click on a mesh and then like log out information about it. We might end up wanting to do that to help us debug things. Where is the, say, damping? This is an example of damping, right? Whoop, demo. Damping. Where are they doing the damping? So they got some stuff. They got those elements. Oh, those are textures, okay. And then they're doing boxes. Yep, okay, that makes sense. Angular damping. So they're doing it on the rigid body itself. We'll have to get some water. Hey, contact is bothering me too. Holy cow. So let's look at the rigid body. Is there anything here about search for damping? We might end up having to look at the source code. Yeah. That's sort of annoying. We might also be able to do this. So we have angular damping, angular velocity. And this starts getting into physics stuff. Which is fine. It sets the uniform density of this collider. If this is set, other mass properties like the angular inertia tensor are computed automatically for the collider's shape. So we can adjust these so they slow down quite a bit. Generally, it's time to adjust the mass. So we could adjust the density, and that I think will have the same. If we adjust the density, I think that's going to have the same effect as if we adjusted the what is it? The damping? Was it the damping? Linear? I guess linear. Angular would be rotation. Linear would be movement. So when these are falling, they have linear movement. So if we adjust, I don't think we want to deal with that because we just want to adjust the mass. Center of mass is fine. Like we don't need to like adjust the center of mass. It's a square. Like it can figure it out for us. The principal angular and inertia. And angular inertia local frame. I'm not sure what the local frame part of that is. But we don't really care about the inertia either. Adjusting that value is not going to really help us. But if we adjust the mass, excuse me, if we adjust the density, that's going to have the similar effect. As if we adjust the dampening. I'm going to just put it as an empty value there while we go to these docs and see what kind of values it's expecting. And this, I got to remember that we can come back to this too. So this library, React 3 Rapier, is a React integration that works with React 3 Fiber using the Rapier compatibility library, of which compatibility meaning that it is using the Rust to WASM bundled into npm package. Hey Chris, nice using the using that 3D text. I appreciate it. How's it going? How's it going? We have made some progress. Hard fought, but progress. We got to remember to keep coming back to this though, because this is what React 3 Rapier is built on, and I always forget. I don't forget that that's the case, but I forget that we can use these docs because it's sort of built on top of it. So what is the... We want to look at the density. I don't really care about velocity or gravity or any of this. We want to adjust the density so these things move slower. And here, it will end up having the same effect as damping, I believe. Slow down a rigid body automatically. I guess that's going to be a little bit different. If we adjust the density, it's going to be heavier. So like if we... Can we see it here? That. We don't want that. We can solve or deal with that in a couple ways, I think. If we adjust the density, that movement is going to be less that. But once that movement happens, damping will make that movement go from what it is to 0 much quicker. So we might actually end up wanting to use both of these. So where's the density? The default density is 1. So if we set the density to... I don't really know what this is expecting. We're just going to bump the density up to 5 and see what it does. And if we give this a refresh, no jump. We still potentially need to adjust the... I think this is lagging behind. If I turn it off and on again too quickly, I think it just refreshes the browser and doesn't actually I think it just uses it from cache. That still does not feel like what we're seeing. Because this feels good now. I lied. I mean, we don't want exactly this interaction, but we do. Like we're not gonna have them all stacked like this, and they're not gonna all be coming in like that. So that is likely not to happen. But we don't want that like crunchy. Like they're like literally sitting on top of each other right now. Let's see if this is. So we are still getting a little bit of the like things just go absolutely bonkers sometimes. So I think we do want to bump up the damping a little bit. The linear damping is, I think, what we care about because we have locked rotation. So there is, the default value is 0, so no damping at all. And I don't know like what is 1, what is 0.5. Like I don't know how much that's gonna do. So we're just gonna say 5. We'll just see what that does. Their example uses 0.5, so I suspect this is gonna be like some real big, yeah. That's actually not awful. Because I think this is, that will end up help reducing some of the crunching that's happening. We still do want a gap between them. So the question is, how? I don't think the attractors are going to be the thing that we want to do. And like, this stack size thing is definitely going to have to be adjusted to. And like, even if we rely on physics and we put one at the bottom, we want the newest one up at the top, right? So if the newest one is up at the top, we can't just have them all sit down like this because we're not going to be able to like get the most recent one, which I guess in this case is 11, to get that one up at the top. I don't know of a good way of us calculating that. We would have to, so these boxes are going to be different sizes. So, I mean, these last few values are all the same, so it's a little bit harder to see. We change this to, we're just going to say, hello. Whoop, that was a little bit too many L's and too many O's. And if we change this to be, but quite a bit longer, but not, I'm going to say not the longest, and then it's going to try to be the longest. No, I guess not quite. It's close. So what is that going to end up looking like? See, they have their appropriate size and everything, but we get that like weird overlap. And I wonder if that's because the physics is, when we make that adjustment to the size, we are updating the ref. If we said that, we're gonna have an experiment. We're gonna double this, so the size of our boxes should be twice as big. I'm gonna guess, and the text is fine. It looks like the physics is being calculated based on that initial size. So we almost need to like, after we scale, we almost need to get the physics to like update and consider that. Unfortunately, that is like, ooh, I don't even know where to start here. We were actually talking about determinism the other day. Theoretically fully deterministic. Blah, blah, blah. So, I mean, theoretically it's deterministic. It's definitely not doing the same thing every time, though. And we have the exact same data and thing happening every time. So, you know, okay. That looks pretty good. Change the, let's just change the text color real quick, so it's a little bit easier to see. What is that color? Color white. Isn't determinism only required for multiplayer games or real-world physics sims? So we were discussing yesterday why sometimes it does wild things, sometimes it just does this real nice. And we were discussing that determinism sometimes comes into play with this, and that's sort of the like in the diagram of like understanding how the engine is like figuring out where to put things and where to move things. That's sort of like the first split. Is it an indeterminate or deterministic system? And I said I thought it was deterministic, but this didn't have anything that's these docs didn't say anything about it. I was like, I could have sworn that it was deterministic, but I'm not seeing anything about it. For multiplayer games, I think you do want things deterministic, because if my computer and your computer are both rendering the same exact thing, if my computer says does the motion, the server says it's a hit, and I'm seeing it's a hit, so my person is like throwing a ball at yours. If they're not deterministic, yours might be showing something different, and then that starts to get frustrating because, hey, the ball didn't actually hit me. I'm seeing the ball not actually hit me. Why is it hitting me? I mean, then, you know, other variables like latency and all those things come into play too. But if it was like no latency and we're strictly just talking physics system, I think you're right. I think it is only required for multiplayer games. We were saying in this case, though, this being deterministic isn't necessarily a feature for us, because if my physics things do the same thing every time, it starts to look like a video, which sort of completely defeats the purpose. So some of that wild, maybe not with the chat, this is a little bit too much. Some of that wild is actually a feature, but I'm not sure why it's doing that. If it's completely deterministic, I would expect that to always do the same thing. Every time I refresh, I'd expect it to do the same thing. So the question is, why or what's going on that it's doing that? And or is this a bug? We did do a whole bunch of updates. As far we jumped a lot of versions of the package just now because we wanted to try the attractors where we're not in the version that I was playing with. We went from 0.6 to 0.11. So some of that like indeterminism could have potentially been bugs that have been since fixed, and now this is a little bit more consistent. But I think the intention is that it's supposed to be completely deterministic. Because it seems to be pretty consistent now, which is good. I would expect this to look like this though. And what's interesting is we are getting overlap. Like those things seem to be overlapping. They're sitting down separately or differently than these are. So like these seem good. What's that doing? I wish these override controls were. Oh, I guess I can do that. You know, oh man, that's a pretty sweet. I like that like sheen, that change, that gradient there. We might actually need to move the light so like this looks nicer, because ooh, that looks sweet. Right color white. Why is that not white? What are we working with here? Invalid property value. I thought it was just color. I really need to like do more CSS. Well, I mean, you know, I guess it is what it is. I don't find myself doing a terrible amount of CSS these days, which means I always feel like I'm rusty. Color sets the color of an element's text. Can I not do just white? Or do I actually just have to do it this way? Ah, okay. It's not a string. There. I don't mind that. And while we're at it, let's do the font family. What do we got? We're gonna go with impact right now. In some of the other text that I'm doing, ooh, that's a little bit hard to read. It's fine. It's fine. Let's see what it looks like over here. I've been using Roboto. Is that what it's called? I don't actually say it out loud. I just use it. I've been using this on my sites this on my like main site for a fair amount of time. It works. And then there's the some of the bold ones work for the headings. So this regular might be fine. Yeah, just like a regular might be fine for that. So I think I'll end up pulling that in here eventually, but we'll just stick with the impact for the moment. Okay, so how... Like this feels fine. And we've got them in order, 11, 10, 9, 8. We need to get them all the way to the top. And I think that's gonna be the tricky bit. Like we almost want them to like move in slots-ish. How do we do that? We want a gap. I guess the gap is probably going to be the first thing that we need to figure out. If we stick with leaving these in physics, which I think would be fun, we do need to figure out how to put a gap in there. Is there anything that can help us with that? In rigid bodies, we've got user is free to set its next position and body velocity. Okay, so we can set the next position. So we might be able to do something like this. Because it's kind of in this vein, but then we would have to calculate the positions, and then we started getting in this like painful loop where like the position of this message then ends up being theoretically dependent on the position of everything below it up until it hits the floor, whatever the floor is there. And And here, yeah, directly changing the position of a rigid body is equivalent to teleporting it. And this, I think, is why we're getting stuff that is not terribly deterministic. The nice, it just sticks there now. When we first put them into the scene, we are effectively like teleporting them into position. And if we teleport them into a position where two of them are overlapping, things just get super wonky. And I think the odd behaviors are why things appear to not be deterministic. That's just my guess. Yeah. But see, like, it reminds me of the old school semantic marquee element. Just the slow. I like it. So we might be able to do the kinematic position, and then we would have to calculate the position ourselves. And then we'll be setting the position of each, and anytime we remove or add a message, we will update the position of each. And the physics system will help us figure out how to get them into that position. So that's a possibility, but we're going to have to figure out and using that would let us deal with the gaps. We would be able to. Would we be able to? We can set the position for each one of them, so we can have a standard gap between them. But then within each element needs to know its own height. But then the parent is going to have to know like the height of every element to be able to like figure out where the like origin of each one of those is. So that we might need to do that. But I would prefer to do it in a different manner. Interesting. Continuous collision detection. Okay, I mean, that's fine. So so you had mentioned, can you add another collider to the entity? That was the other thing that I was wondering about. So we'd upgraded so we could try the tractors, which were a newer thing. I had definitely not seen them before. But that's sort of like, I thought it was wrapping and telling a rigid body it is now an attractor. But it's actually a completely separate body. Completely separate from like a rigid body. So I don't think that's going to work. Now, a collider. We can, in here, we can set the collider. So we get default values, and we can also disable auto generation. Now, if we disable auto generation, I don't know what that means. I presume we need to somehow calculate it ourselves. Control by setting the collider's prop on the rigid body. So I think there's potentially two ways we could go about this. We could do an additional collider that's above. So we've got a group that's got the two elements, one with like an invisible collider and one with the one that we care about. Or we could potentially calculate the collider ourselves. Normally I would say like, yeah, give me auto everything. But it's a cube. Like it's not going to be awful to calculate it ourselves. do they have? I wish I knew like where these colliders were coming from. Okay, so those must be things that you import. So if we have a rigid body and a sphere, we are setting this to be. We're adding 2 colliders. Okay. So maybe what you're thinking might be a good way to go. Because we have one rigid body, we have the mesh we care about, and then we have colliders. Those colliders can overlap the meshes, so they're like 2 different planes of existence, I guess. So what we could do is we could do our rounded box, and then we could have 2 colliders. So if we turn off all colliders for this, you can control the default by setting the colliders prop on the rigid body or change it globally. Okay, so we got the option. I was gonna say this would be unfortunate because if we are putting other things in here, we might actually want to auto-generate those. In this case, we don't. But if we can per rigid body say colliders is false, that might be the ticket. So we got our physics system, and we've got a group of all the chat boxes. If we set our physics collider for the rigid body to false, we should not have any collision events anymore. So these should let's just give it a refresh just in case. Oh, interesting. By setting the colliders to false, we have now removed. We have removed it from the physics system, basically. Is that how is it the same as fixed? It's definitely not fixed. Interesting. So this is our element. Let's try putting in colliders and see what that ends up turning up. We want a mesh collider. Hull is probably fine. Do we just do that? And I'm not sure. So if we've removed the mesh collider, or if we've removed colliders, auto generation of the colliders, does that mean we've removed all the damping and stuff that we've done? Or is it going to also calculate those? Is the rigid body going to be a combination of the physical properties of each collider? That's probably the best way to ask that question, I think. Mesh collider. So this is make a compound. So we can do custom. Use an automatic ball collider for all meshes. Okay, that's like sort of what we had before. Automatic. We here are doing a compound, so we don't have any colliders, I guess, for this. In this system, we've opted out of all automatic generation, so you have to opt in. So this has no collider generation, so we're creating 2 separate colliders. Here we're doing so the rigid body has a ball collider, and we're overriding that with a tri-mesh and a hull for these 2 cases. This is going to have a ball, and then we have 2 additional ones. 2 automatic, an automatic ball, which is this, and 2 custom ones, which is this. They've got it kind of written backwards from how I would personally read it. So that means that what are our collider options? Collider? So I think we want to do creates a convex hull collider based on the mesh's geometry. I think in this case we actually do want to do a cuboid collider. So if we turn it off, for the rigid body, and we do a meshed collider with a cuboid, and we do this, that's going to put a collider around this box, much like we had before. Equilibrium. Thanks for stopping by. Yeah, we're back on React through Fiber for a little bit here. We are trying to get our chat events into our React through Fiber scene with physics, which is why we are looking at colliders right now. I was gonna highlight this up here. That's kind of hard to read. We are looking at React through your APIs, so we can put the chat elements into our physics scene within React 3 Fiber. Oh, I know. I had the hardest time getting, it's R3F. I always would mix up the 3 and the fiber and say React Fiber 3. I'm so happy I finally got that like straight. I don't even know if it's just like straight in my head. I've just set it out enough now that I feel like I mix it up less. Okay, so we've got a mesh collider. We got errors, yeah. And yeah, we didn't import that. It was kind of weird that there was nothing there, and I wasn't quite sure why immediately, and I'm like, why are there no errors? There were errors. React Fiber. Okay, so now it's in the physics system again. It's still weird that it's just like overlapping a little bit there. Like I don't get that. If we turn it on, that was probably too fast. We're getting overlap. Curious. It seems like the top ones are fine, but the ones on the bottom are not. That could have something to do with it. I'm actually curious now, like, what happens if we add a new chat message? That's not what we want to happen. Especially that. It just goes, oh, dunk. It sticks. I don't know why it's sticking. How do I turn off sticky mode? I think part of what's happening is here we have a scene where we can move around. So there's some expectation of like us being able to see it. This is being rendered, and we can only see this. So I think once the element is outside of render distance, it's like getting rid of it. And that ends up being interesting because, well, it shouldn't affect our state. We are putting these in here as a map based on channel alerts, and that is state. So like this would be set state. Yeah, we should be just adding it. Oh wait, what? If it's greater than 10, then I wonder if our logic is just wonky there. We'll have to come back to that. Getting distracted a little bit here. Is the text using plain geometry or HTML? It is using HTML from Dry. And something that we struggled with, well, I know it was going to be difficult. I would say the obstacle that we had to clear was Dry puts in HTML. That HTML does this thing where it can expand the container depending on what your CSS properties are dynamically. But if we have multiple lines of text, that's all dynamic. We can't like hard code that. We need that container to expand, and then we need the, whoops, bumping my mic here. Then we need the WebGL element to also expand to match. So like if we put in the text, we don't want this to happen. We want that to happen. Love the hand motions. So that was the obstacle that we had to clear, and it's possible that could be affecting how our physics are reacting to. But otherwise, the HTML from Dry has been super neat to work with. I would like a little bit more on the docs, but you know that's it is what it is. We figured things out. So it is coming through. It's not. It is. That's actually HTML. We do use the text to WebGL text looking elements as well. If you do exclamation mark 3D and any text, we get like a 3D thing here. That's also using a Dry implementation, and that is using the text 3D. So it's way more to your question than you actually asked, but option B is the short answer. Materials. So we got those coming in. We've got our colliders working. So now if we put a collider, an additional collider in here, that's just we don't want a mesh collider. We want so we use the cuboid for the cubes, which feels bright. We're gonna look at doing a compound. And I think that's probably gonna be the easiest because we can set the size of that custom collider as a completely separate element. And that's sort of in the vein of, I guess, what Chris was surmising might be a good way to go, and I think that is going to turn out to be a good way to go. Position, friction, restitution. Typo here. Whoops. We might actually want to come back to that too, because we're getting a lot of the bouncing. I feel like the damping that we have in here right now, slowing the motion, is nice. But we may end up wanting to tweak the restitution. Mass properties, damping. Where's the... We want the... I guess we kind of have to look at this. So we've got a cuboid. We don't really want to put an additional box or rigid body in there. I think we just want to do... We don't want a mesh collider. We want the cuboid collider. But we don't want to actually use the mesh auto-generated one. We want to add in an additional one. So we want to say, let's add a cuboid collider. And that needs to be imported. Gonna drop. Good to see you stop by. Rust release video. Ooh, is there a new version of Rust? I missed it. I've been busy lately and haven't really kept up with the Rust news, as it were. So I'll definitely have to watch. But thanks for stopping by. All right, cuboid collider. There's a viewport container in use3 hook, and I guess you could use it with useRef and dynamically set the width of the HTML container. That's kind of what we're doing. What we can actually, since you're asking about it, we can take a look at what we ended up on. The 166 today. Wow, I feel like 165 just came out. Nice. Yes, so there's hooks, and I think your mention about useRef is sort of on the money. What we ended up doing was we have a few refs in here. We've got the mesh message box and API. The mesh is our box, that square. Message box is where that's the HTML element that the text is within. And what we're doing is we're using that ref to get the height. I think scroll height, we saw that. I didn't really think about it too much. I wonder if scroll height might not be the best height to use. But we get the size of the HTML container, and with some rough conversion stuff, scale up the mesh, which also ends up scaling up the HTML. So then we do the opposite to convert to scale the HTML back to its original size. This feels, and you can see I'm only focusing on the height. This doesn't change our width. I'm pretty sure it's going to be just fine hard coding that. If our camera angle or anything like that changes, it's going to be a little bit more painful to deal with. But we can hard code that because that's never going to change. It's the height that was the pain, because that's dynamic based on the amount of text you have in there. And I think the best way to go about it is scaling. I couldn't find a better way to deal with it because we have sort of a complex shape. It's not just 4 lines connected, because it's a rounded box. Wherever it is, it's a rounded box. So we would have to like adjust the size of 4 lines plus the curves, and I'm just not doing that. So scale felt like the best way to go, but using scale meant that the text also scaled up in height. So like if we would take this off, we could, assuming we can actually see stuff right here right now. What? Slice. Forward ref. What would I just commented out this, right? Transform. Oh, I put the cuboid collider in there. I wonder if that's causing an issue. Yep. Yeah, let's take that out for a second so we can. Yeah, that I think it has some properties that are required, and we're not putting those in yet. So if we take this off, we can see what the text does when we scale up the box. Yeah, there you go. Some of that text is tall, some of it is not. So in doing this, the text also scales with it, which is cool, because that means that zooming in and scaling an element or whatever, like if we get that text nailed in with HTML dry helper, it seems like it's just going to work, which is really, really nifty. I'm surprised how well it works. But in our specific case, we don't actually want that functionality, at least not for this. So on every frame render, we're just like resetting it essentially. So performance wise, it might not be an issue. It might. But we're just going to roll with that for the moment, and then we'll deal with it if we need to. And like one of the things we see here is that it seems that in scaling the physics stuff might not be considering that correctly. Because I'm guessing that this mesh collider is being sized based on the height of that like the collider that's created is based on the original mesh size. There we go. That's the best way to say it. And we adjust the mesh, it's bigger or smaller, and then the collider is not coming with for the ride. Okay, so we added a collider. We likely need to do, I don't think we have to do the type because it's sort of built into the collider, but there's probably going to be an args. So I'm going to guess that we're going to need args in position, and I'm presuming that that's why we were not having a good time there. And these values are going to be very similar to our boxes. So I'm actually going to make those the same for the moment. I'm going to make these the same for the moment. So that will make our collider exactly the same as our box. So we're actually going to have two colliders on top of each other. I'm not sure where the position is at all relative. X is going to be fine, Z is going to be fine, but the Y is going to be different. I'm times gap minus gap, maybe? We're just going to throw that out there. Yeah, a complete educated guess. We'll see what it looks like. So, like, it seems like there are colliders. We can throw into bug mode. I think that's going to help us out here because there are colliders, multiple colliders, some of which should be around those boxes, some of which we won't be able to see at all. So being able to see something is going to be helpful here. And now when it looks like these debug wireframes are color coded. So everything is settled. They're considered sleeping, of which it's not going to be doing the physics calculation on it until they're awoken again. The bottom one is fixed. It seems to be yellow. So if we refresh, you can see when it's being calculated, it's pink. When it stops moving, it turns to like a maroon, I guess. And you can see we've got some colliders in there, but positionally, they're sort of showing up odd. So let's go ahead and look at one message. Let's see if we can kind of figure out what the collider is looking like here. Actually, we need to do, should we do two and not fix the bottom one? So we definitely have two colliders. I think we've got one that goes around the text and one that's like this. So that would explain why we're seeing sort of odd behavior. If we strictly take off this and we just have that mesh collider, what is that going to look like? So the collider is, and this actually makes a lot of sense. This explains why. Yeah, it looks like that collider is based on the initial calculation. So we almost need to change the calculation or the size of that collider based on the size of the box itself. You think scroll controls from dry might be helpful instead of setting the height dynamically. You could set the height of the HTML container with scroll. Well, see, I don't think I want to set the size of the HTML container. The HTML container is going to be, I want it to be whatever size it needs to be. So if that was a big chunk of text there, I guess I'm looking over here. That's a big chunk of text. That might take up 4 lines, but somebody that says, one word, it's only going to be 1 line. So the box that contains it is going to be smaller or larger based on that. So I don't care what height it is. I just need to know what height the HTML thinks it should be. And then I want to match my WebGL element to match that. Does that make sense? Or am I just completely missing something and I have been going in the completely wrong direction? So you said scroll controls. Scroll. Keyboard presentation scroll. And so this is I think this is another bit that we don't need actual scroll controls. Because I'm not scrolling. This is just a web page that's showing up on the overlay. Ideally, once it's rendered and shows up once, I don't want to have to touch it. I don't want to have any interaction with it at all. The only interaction that I want to have is to affect the elements within it programmatically. So if you type in, a chat message, that should create an element. That's the only change or response that I want to see happen. I don't actually want to scroll in this component at all. So the scroll event, I want to say it's not something that we are interested in. The scroll height is an actual DOM node thing. So if we would go mdn scroll height, that's just straight up a DOM node element or a DOM node property. So it's the minimum height the element would require in order to fit all of the content in the viewport without using a vertical scroll bar. And that feels like the right answer. It doesn't include the border, margin, or horizontal scroll bar. And here, okay, this was the question I was worried about. Scroll height is equal to client height. Because we don't want a vertical scroll bar. So in our case, those are going to be the same. So I think using scroll height is going to be fine. We could actually get a fractional value too. We'll put it back in that one. But we just need to, when we have a set amount of text and it renders, we want the DOM node to say, hey, we have rendered. It is this many pixels high. Do what you will with that information. And then from that information, we can then scale the mesh itself. So I feel like that's still the way to go because we don't want any interaction with the web view or the view itself, which is what the intention of the scroll controls is. Okay, so if we, why is it super blurry? I'm actually curious too, what does it look like when we do emojis? I don't know that I've tried it yet. I saw you had an emoji in there and there was something in there. It works. Sweet. Nice. That's pretty sweet. Okay, so we've got, let's see. What is, we've got a fixed, so the as far as the physics goes, here we can actually reset it. Let's reset it over here. Let's make sure they match up because this always seemed to be slightly different, and that's confusing. It must be something with how it's rendering it or something. Because that looks fine in the debug, the squares around it and everything. Those seem to line up really well. But they don't here. It's like on the content itself, which is confusing. But this is what really matters. This might be more current. This is going to be a newer version of the browser than what is being used to render that. So it could be that something's changed from here, this browser version, to this browser version. So we'll need to keep an eye on it. But I think we call it okay, and we try to toss in this other collider and see what it does. And see, now we get plus gap. So the height is going to be y. What is our gap? Gap is 2. We might not actually need to. We might actually need to adjust this. What is this going to look like as far as this goes? See, now that one looks way different. That one is starting to. It now looks sort of like how that is, and now they're kind of matching up here. That is confusing. All right, box X. Don't you think it has more to do with CSS or DOM than R3F? Maybe resetting your CSS would help. I think you are kind of on the right thought path there. And I think that's what we ended up settling on. So the HTML helper in Dry does much CSS for you. And part of that is transform is true. Transform is true, sets the translation and the matrix 3D stuff. So like if it tips and falls, all that text tracks with and does all of that. And then it also, I think it also helps enable inclusion. To occlude, I think you have to have transform on. Don't quote me on that, but I'm pretty sure. And I don't want to do the inclusion or the matrix 3D stuff. So I think it makes sense to keep these on. But it meant that I needed to do a little bit of CSS, which this ended up kind of being the trick here. Well, I guess mostly just the width. Did I do any actual the width, and then I adjusted the position. And I think this is actually resetting it to 0, 0. And that ended up being the ticket that sort of like centered the text in the box. And I think coming back to your thought about resetting your CSS, I think this is effectively doing that. So this React component ends up getting translated into a bunch of semantic HTML elements, of which it looks like those are doing a whole bunch of moving right now. It looks like this. So this container, CSS modules, so the names are a little bit wonky from what you'd see in our code, but that's the container element, and then everything above it, that's all that HTML. Seizure warning. And like that transform Is it transform, right? Yeah, transform and occlude. Particularly the transform. That's dictating these pieces. So we sort of had to like, after it does all the transform, we had to like make sure it fit in there properly. Um, and I think that's mostly where it ended up fitting in. But the all the HTML all the HTML worked, but without that property, the text could get longer than the box. So we needed to adjust the box to fit. So if we take out all of this jazz, we can see what it looked like before we kind of came to that conclusion. Ethan, good to see you. Thanks for stopping by. Can we really see it here? Yeah. This one's kind of like overflowing. The text is white now, so it's a little bit harder to see, but you can see it's overflowing the container. So we need to the WebGL element somehow has to react to the size of our text. So if we using the refs figure out the size of the text with a little bit of conversion, we can make the rectangle bigger to fit the text. But by doing that, we're scaling the rectangle, which also ends up meaning that the HTML helper scales the text to match because it's saying, hey, this mesh is being adjusted. We're going to follow that. So then we just do the opposite, just the text. Does that make sense? This feels convoluted, but like it appears to work. So if you got any other better way to do this, I'm not trying to I'm not trying to what's the word I'm looking for? Um not prevent, but like I'm not discourage. I'm not trying to discourage you from, helping out or throwing your thoughts out there. But like we spent a few hours on this yesterday and it's still really top of mind. So like I know how I came up to it just off the top of my head. Uh so we spent a whole bunch of time on this and I mean it seems to work, but if there is a better way that we missed, I'm, happy to entertain it. Okay, so we have two colliders in here. Positionally, though, I think this outer one is the actual collider. And the other one is the mesh around it. So if we do the location and the thickness gap doesn't feel. This seems way bigger. Unless it's the one right above it. So the big wide one appears to be the actual collider. So if we make that real skinny, it doesn't actually seem to be getting smaller. That's sort of the confusing part. Okay, well that's smaller. The width is still sort of wonky. I'm not quite sure why that width is so huge. The width is here. So if we just say divide that by 3, I don't know why it's. Something feels funky there. I don't know why this is so much larger than the other one. There's got to be some something else that's sort of like making that adjustment, but like this should work. Location is going to be the position. We are minusing the index times the gap. But this is also going to be like kind of dependent on, and this is where it's coming back to it would be nice if we don't have to calculate this. And this is all grouped. So like this feels fine. Whoop, I don't want to adjust that. Let's do that times 2 and that times 2. I just realized that my music stopped. Where are you from? I live in the US, central US. So it is cold right now. Well, not as cold as it could be. It's gloomy, and right now it's like right at that freezing temperature where it's like we're getting some snow and some rain. We'll get a bunch of snow, and then it'll get a little bit above freezing, and then we'll get rain instead, and then it'll melt all the snow. So it'll just gross out. What can you do though? Okay. I gotta get the position of these different. The initial position is gonna be, we're gonna say -7. What's annoying is I'm almost gonna have to get. It's gonna be difficult to get the most recent message up at the top this way. Um, it's almost like what we're gonna need to do is we don't want to teleport something there, but if we reverse gravity for this, that feels awful. If we reverse gravity, it's gonna flow the other way. And then if we say if index equals 0, then we're gonna fix it. And then what we want to do is that first position is going to be we've got a rigid body and then a group for the whole thing. So this rigid body, both of these have positions. Let's take off this. That's going to give us a collider. That's still a weird, like 2.5, I guess. I don't feel like I'm missing something that would make that calculation clear. And right now they're like overlapping, which is not what we want either. So what we need to do is say the first location is going to be up at the top. And that's a positive number. And then From there, we need to do the index and then another height. And we're going to assume that, say, each box is something like y times 4 to start out with. And I think we just start with a whole bunch of like empty text boxes basically, and we'll shift them out. So the first box location minus index times I guess it's basically like the box dot y times 5. And then gap times 2.5, I guess. That feels odd. Isn't there something margin like think and rapier to avoid the overlapping? If there is, I haven't seen it. If you can find something, feel free to drop a link. But like it feels so this collider I think is basically going to act like a margin. So we're going to have a collider there. We almost have like two dimensions. We have like visual reality and physics reality. They can overlap. When you do a rigid body around a WebGL element, if you use auto generation, it's theoretically going to get real close to where they are one and the same. What we're doing is we're doing that. We're turning off auto generation, but manually doing one auto generated one. And then we're also doing a second collider, just the collider, not the mesh, that is like sitting on top of it. And that ends up being the margin. So you might actually be thinking exactly what we were thinking, where this little additional collider acts like a margin, which it's not terribly visible in here because it is just like completely overlapping. But we've got here. I'll shrink this so it's a little bit easier to see. This is a rounded box with an auto-generated mesh collider. This whole rigid body has colliders turned off or set to false, so it's not going to auto-generate anything. This is like a custom collider, and that is the thing that's serving as the margin. So we can actually do this is serving similar to a margin. This enables, why am I actually in? Oh, okay. Let's do this. This enables auto generation of the collider for this mesh. That messages come in late. We'll have to play around with the ordering. Oh, music. Yes. Put a little bit of, what time we got? I've been going for about 2 hours. I think I'm gonna get these elements just like separated out well enough. I don't know if I'm keen on having the physics flipped because that feels odd. And I'd like to have everything in the same physics system, so we might need a better solution. But if we want something to work for right now, so as it is right now, they're actually gonna go up. They're like a whole bunch of balloons. And maybe we can actually do. We'll have to check on this. Maybe we can set the physics gravity different per like group. So like if we have one group that's all the chat messages, we could have gravity go up, and then everything else gravity be down. That might actually work because then we can put it all in the same physics system and they'll interact. And like you drop something out of the this with a command, you can run into the chat messages and like bounce off of them and stuff. Okay, so cuboid collider. We have set the size here. I think that's a good size. So this is, I think, what we're gonna have to play with. First box location. See, that's a little bit of an odd thing too, because is that the top left or the bottom left? I'm assuming it's left. It could not even. It could be like the center or something. We're caring about the height, so this left to right to center doesn't really matter. But if it's at the bottom, if we set the first location to be the top of the frame, we're gonna basically cut that off. So that's a little bit of an oddity. And then from there we're going down. Right in the center, like right here-ish is 0, 0 in our scene. So anything down is negative. So to move things down positionally, we set them to be negative. We're all popping new messages in is going to be kind of a pain too, because we'll have to pop them in. We'll have to set them at the top and then like shift it down. So we're gonna have to like, oof. Although that might actually be the saving grace if we can use frame to like shift it down every time, and the top message, the index 0 is if that's always right up at the top and it's fixed. That might be the saving grace here, because then we could just new messages actually appear above and get shifted in, thereby pushing everything else down. Okay. So let's look at this position. We need to adjust both. That's the other piece of this. Is the index and box Y. We're actually gonna pull. So this little bit here is to. Oh, okay. So box Y. If we have the position to be the same, we're gonna have each collider on top of each other. We want to shift the margin collider up above, and that needs to be shifted basically half of the box height and half of the gap height. So this is going to give us a good location for the box, and then the collider needs to be here. We're gonna say gap const initial position, I guess. And we're going to say that index times initial position. And then to shift this one, we need to do initial position divided by 2 plus gap divided by 2. Gap is going to be the height of that margin collider. Better. So this little box up here is the. Can I zoom in? Is it gonna? Oh boy. Okay, this box right here, that's that collider, and this is the margin collider, the thin one. This is our content, that like auto calculated mesh. So we're definitely gonna have to like readjust that auto calculated mesh, I think. Although we did say it was working here, didn't we? Yeah. It's actually much easier to see here. Wow. So that gap, we definitely have way too much in there right now. Oh, because we're doing a minus here. This whole thing, we should be minusing that whole thing. So we're doing an initial position, minusing that, and then we need to go back up. Oh, maybe that was right. So we need to do plus and plus. This is actually dependent though on index. Which actually makes more sense to be this. Math things. You know, in school there was always people that said math and physics. You're never gonna use it. Why are we learning it? We're kind of using it. What's that look like? That margin collider is still really high up in the air. Why is that? So the margin collider is still much higher than the collider that we care about. So if we are minusing, look at something with that initial position that we're thinking about. So this should put them right on the same. What? Divide by 2. Okay. So that puts them on the same. Ah. Um. So we need to do plus. I think this plus gap is good. Let's put that in there. That'll shift it up just a little bit. And then we also need to add in, we're doing index plus initial position. Initial position is like, we're just spreading them out and letting the physics sort of like handling that positioning for us, which is sort of in the same vein as CSS, just kind of a different way to think about it. So the initial position is bigger, but we do want to consider the index, and the index is going to be index times box.y divided by 2. But also the box.y is going to change as well. So like the taller boxes are going to be different. So we almost need like a relative position based off of that too, which is the other complicated thing here. That doesn't look awful though. I think we almost have to adjust this cuboid collider as well, because the rectangle that we have, or that square cube, I guess, that we have is getting taller. And that's dynamic. Dynamic based off of the center. So it is, we've got the center point and it's expanding like this. We need to know this height so we can appropriately position that cuboid. The cuboid collider. Because these two colliders are in the same group, so they're not going to move relative to each other. But that doesn't look awful. The does not look awful. That's for sure. Let's turn them all on just to make certain that we're not missing something when we look at all of them. But we should ideally have the first message be pretty close to the top. Yeah, see, like this isn't. Obviously, there's some like, whoa, they like pass through each other. You're from Sri Lanka. It's 2 a.m. there. Yeah, no worries. That's part of the value of streaming here on YouTube now. The replay is going to be live the moment. I mean, you could actually rewind it if you want to. So, the moment I hit stop, you'll be able to watch the full thing and seek anywhere within it, which is pretty great. I don't have to feel guilty for doing a stream on Twitch and like taking 3 weeks to get it on YouTube because I get busy. I mean, the only downside is that if I don't touch it for 3 weeks, you might not have like the chapter markers or whatever, but like at least the content's there. Anyways, have a good night. Thanks for stopping by. Feel free to drop some comments after the fact when you watch the replay. Would love to hear from anybody. Okay, so that gap is still kind of funny here. I don't know what that is. That looks like a big gap right there. They're still like kind of overlapping each other. So this is the last bit I think that we'll want to try to tackle before we call it a day. The calculated sizes of our colliders also seems to need to change. Which ugh. Now if we scale this, if we scale the mesh, are we able to like group these? Could we do a group and scale the group? Our margin is going to change though. I kind of want the margin to stay the same, honestly. I want the margin to be standard across all of them. So the gap needs to not scale. So the gap needs to stay the same. But the position of the gap, the position of this cuboid collider needs to change if this changes. Can we like adjust the origin or something? Because like that would be just so much more helpful. Everything is from the I guess what we could do is stop searching. I don't think we can change the origin, but I think we can actually change the center of gravity, which normally would get really wonky because if you adjust the center of gravity, it'll make things like, especially for things that are well balanced, it'll make them spin more than they normally would. But we've locked rotations and we've locked some translations. So it can really only move in one direction anyways. So if we adjust the scales, if we adjust the positions, will the positions be adjusted based on the center of gravity? Like that position, where is position defined from? That's maybe a good question to first answer. Position, rigid bodies. Position is its location as well as its orientation. Stored in, oh, that's the bevy. creation and insertion, position. Position of a rigid body represents its location. Position can be set when creating it. It can also be set after its creation. And if we set the position after it's created, we're effectively teleporting, which is what this prompt is saying. We can manually set positions if we have kinematic positions turned on. The default is dynamic. So currently they're dynamic, so we don't have that turned on. But we do need to like insert it somehow. It doesn't really say anything about like where. Okay, see, oh, there is a gravity scale. To a value other than 1, the magnitude of gravity applied to the body will be multiplied by the scaling factor. Hey, so we can set, we can put them all in the same physics system, and we'll just flip gravity for these. So that'll work. So I think this, if we can get the top chat, or the most recent chat to appear above where we can see, and then shift down and bump everything else down from there. I think that is going to be the thing that we need to do to. We'll have to. I mean, there's a sleeping thing that we need to consider, but I think that's going to be the thing that'll make this feel well or work well. We'll have colliders be margins. Each of these chat boxes is going to be its own collider, and then that custom collider is going to be the gap between them. And one pops in and shifts down, all the other ones are going to like be pushed down as well. I'm liking that more and more. So the first location, this math is still kind of wonky because we, I think, need to figure out how to adjust that collider. Let's toss a ref on here and see what we can get out of it, and see if we can even edit it. That might be that might not even be possible, and if it's not possible, I think we're gonna have a hard time. Mesh collider ref. What is it? ER? Yep, collider. Ref equals this. And let's just go ahead and log out the collider. And then we're also going to do a gap collider reference. And that's going to be this one. Ref equals this. Let's actually put this one at the bottom, so they're reasonably consistent. And let's look at this gap. Did my music finish again? Did I just pick a playlist that was really short? Here. Let's put those on the same one. Let's take a peek. What is this looking like? So we've got a bunch of colliders in there. We should have, oh, I need to go into console. So we get the gap. There's a current. The mesh collider is not set. Interesting. Handle, shape, parent. The ref here doesn't seem to be helping us. We might be able to get somewhere with the API ref, but I am not certain. This might be where we need to like start digging into things a little bit. See, so this is sort of the this would be like if we want to remove or deal with a specific message. So like if we need to delete a message comes in and it needs to go, we could use one of these. There's the add force or apply impulse, maybe is the better one, and we could effectively just like yeet it, go whoop, and just push it off the side. And hopefully it doesn't affect this stuff too much, but you know. And we've done some with the locking rotations and translations already. Reset forces. Translation. Yeah, I mean, I don't think we want to like set any of this. So what's the handle? Oh. Damping, linear velocity, angular velocity, rotations. I don't think that's really going to give us anything we want. I'm not sure why this mesh collider ref is never set. We might want to just do a custom one. If we can figure out how this gap one works, and we can adjust the gap one, we might end up wanting to do the mesh one the same way, rather than having it auto-generated, just straight up manually calculate it. Half extents, a quarter. So Y and 575. .875. So I guess X is half. Can we affect these at all? So we can set colliders, we can set their translation, rotation, friction, and sensor. We do want a solid collider, because we want other things to interact with it. Round mass properties. Set mass. So there's a position. It's not specifically position though. Set the collider position when the collider is created. So it's setting the translation and the rotation here. Set the collider position after the collider creation. So after it's created, you can also set the translation. So that's going to shift it. Okay, so this is kind of what I think we want to do. There's a directly setting the position of a collider attached to a rigid body will have no lasting effect. Instead, it is possible to set the position of a collider relative to the rigid body it is attached to. So what they're doing is set translation with respect to parent. And I think that's actually what we want. But the question is, how do we get access to that API? We have the gap collider ref. We could look at, like, that might just be here. So, I mean, this looks just like normal object prototype stuff. Where would they do it? Collider set? Height set. Okay, so it is here. So we can do gap collider.current, and then these are all the methods that we could do, of which there should be a set translation with respect to parent. So we can adjust the translation after it's created. This is going to redo it every time. Well, I'm going to have to figure out a way to like just fire this like basically once. We'll have to think about that. We might need like a local state kind of thing. So fire it off once and like actually translate it. And then once we have done it, just stop. So cuboid collider ref. So if we adjust the scale of the mesh, it's coming in at 1. So if we say our position initially is going to be the exact same as our make both the box and the custom gap cuboid to be on top of each other. Now we just need that difference between those. So we need the height of the mesh, and then if we do mesh ref mesh collider ref dot current dot set set translation with respect to parent, I think is what it was. And we can adjust the X, and we don't want to make an adjustment there, but we do want to adjust the Y, and the Y is going to be, if they're right on top of each other, we need to move the gap up half. So it's going to be gap divided by 2 plus whatever that height is, which we have calculated with the height mesh divided by 2. So that should set the collider position correctly every time. Nope. Did I spell that incorrectly? Current. No. Set translation with respect to parent. The uncaught. Cannot read properties of null. So, like, we're gonna have to do some. Like, we're not gonna make this adjustment if we don't have all access to all of these things. this and this. Like, we kind of need access to all of them, and we can run a few frames without actually modifying them. That's fine. Now the height of the box isn't working. And that the mesh collider, or the gap collider, is not adjusting either. Gap and height of mesh divided by 2. Set the collider position with respect to its parent after the collider is created. It almost seems like it's not firing at all now, which feels weird. I mean, it's stacking. Like, that physics stuff looks fine, but now the meshes are not as big as they need to be. So if we just care about the message box, this should recalculate every time. So I'm surprised that we don't have those refs. Because if we do this, it's going to complain because we don't have access to it. Because it doesn't yet exist. So like we almost end up having a race condition is sort of what's going on here. Use frame is going to run on every frame. And then as far as that's concerned, we have a bunch of refs, which is just, oh my gosh. This is kind of the way it goes, I think, with this. The gap collider ref. Oh, wait. We don't need the mesh. We need the gap collider ref. And we're adjusting this. There we go. Okay. Okay, that's better. Because it's, you know, I was about to say it seems like that was always available, but it's not. Message box, mesh ref. Alright, what does it look like if we do this? Let's empty the cache just in case here. I don't get what gap, message box, mesh ref. So if all of those are available, then do the thing. Gap collider ref.current is not a function. Do we have access to these? So it seems like actually the ref is there, but gap collider dot current dot okay. It's actually looks like we got an array or something in there. It's actually this. There's the 0, so it's an array. Oh well, and it says array right there. I just completely overlooked that. So that's actually within an array. There we go. Are they coming in? Just to keep resetting it? Yeah, it's just firing that off over and over and over. Okay, which that makes sense. But I mean, I really only need to... I guess I really don't need to do that every time. I've got a thought. We're gonna put the use frame on the side. Use effect does something very similar. It's going to fire a side effect at a certain interval, of which we are going to determine based off of these things. So if any of these changes, let's refire this and recalculate it and reset it. And then that way it's only going to set a handful of times, theoretically. So we've got a couple of refs. We have API, mesh ref, mesh collider, whoa. Okay, so we got some like just text showing up here. What? What does that actually look like over here? What? Something was about how it's firing. So do those not change? We are getting these to fire once. So it's going to fire once when it loads. And if all of these are set, then it's going to do the thing. I don't actually need the gap. I do need the mesh ref there because I'm setting that. I do actually need this because to change everything I need this to layout. So if I do something like this and just say every time any one of those changes, let's try to refire this, and we'll say if mesh ref.current, then do these things. And if gap collider.ref.current, then try to do this. There's stuff coming up. It does seem like it only fired the once though. What does it look like over here? Like we're getting text. So something is going wonky with that, and that use effect may not actually be the thing to change. We could fire them. What's this use frame? Let's double check the docs for use frame. Execute code on every render frame, like running effects, updating controls, and so on. You can receive the state in a clock delta. It runs at the native refresh rate inside of a shared render loop. You should never set state in there. Your calculations should be slim and should mind all the commonly known pitfalls when dealing with loops. Okay, fair. So doesn't seem like this is actually what we want to do. If we are just doing this though, I really don't want to. I mean, it even says it don't set state in here. We can. If we fire this off as, oh boy, I'm not quite sure. I'm not quite sure what to do with this. It feels like use frame is gonna end up being what we want because it doesn't seem that those references actually fire off anything to trigger the use or the use effect. And it seems like we do want to do this. This doesn't actually seem to like a reset every time. So if I should go grab my water. The meshRef.current. We only need to do this if the meshRef is there. If we do something where like we dump all of this in here. Because we don't care about this calculation at all unless we have a scroll height. Which is the outer one. And if we have... Actually, I don't even need the children here. If we have the message box... Yeah, like we're basically at this then. We need all of this to change anything, to make it worthwhile to like run this at all. So if those are set, go ahead and run stuff. But then we do want to just skip that if the the other thing isn't set. A bunch of these will end up being changed multiple times, and like there's got to be performance hits with that. But clearly something's getting translated to where it's not actually showing up. Because if we take this back out and run this, that's fine. So something with the setting the position of the gap collider does not like. If we just check to see if it's set, and only do this if it is, what does that look like? So it's definitely there. And that collider is definitely standard all the way across all of them. So if we do console.log gap collider ref dot current, that's going to give us an array, right? If we say this, what is that going to give us? Do we have we've got prototype stuff in there, shape, parent handle. We should be able to do the prototypal stuff, of which we've got set translation with respect to parent. Do we have to do that prototype? I didn't think we had to. I thought that was only for a setting. Yeah, it's undefined. So let's take this out. So if we set the translation with respect to parent, let's do -2. And we'll leave those in there. I think height, we might want to just try hard coding it and see if we get any values in there at all. It's just going. There we go. Function components cannot be given refs. Attempts to access this. Did you mean to use React forward ref? Possibly. So we might not even be able to give a ref to the collider. So if we've got the gap collider, this mesh collider ref might not actually work if we're using this default one. We might need to use a custom one that just would be the same exact size. But you can see even if we do that, like those just straight up disappear. So it seems like any of these things that we do here are not going to work. We could set the rotation. So rather than doing this, let's say gap collider ref dot current dot this, and let's see if we can actually get these to rotate. Is it just something with this function specifically? They're not turning. I'd expect those. I'd expect those refs to be rotating, but they're not. So something about that is funky. Rigid body on collision enter. What does our API look like? That's going to be the other piece. We've got a ref to the rigid body, and that seems to be kind of the expectation. Console.log API. We might be able to actually like loop through things on the API layer. That would be the other thing I would try. So current has that's for the whole rigid body. What latency do we have here? Do you mean to the stream? Is it I don't see anything in the views. I don't know. Good question. I've got the I think normal latency set. I don't know if I can change it now that I've started the stream, but stream health? No. 30 seconds. Woof. Yeah, stream latency. Thanks for pointing that out. I didn't realize it was that large. Having done a lot of streaming on Twitch, that seems to be more like 5 seconds, which is much more reasonable. YouTube live stream latency. I assumed normal would be reasonable, but 30 seconds does not seem reasonable. How to change the live stream latency? Yeah. Normal latency. If you don't plan to interact with your audience. Good to know. Thank you for saying something. If we do low latency, it does not support 4K, which is fine because I'm not streaming in 4K. What's ultra low? Okay. Near real-time activity. If you want low latency with minimal viewer buffering, choose this option if you want to maximize engagement with your audience. It may increase the chances that your viewers get buffering. Consider decreasing your ingestion bitrate to make sure that your network can sustain the stream. I am curious what their expectation. Okay, I stopped the timer now. Well, and see, there's I got a chat in OBS here that I'm reading. I also have a stream dashboard thing on the other monitor over here. Different computers. That one comes in a little bit faster than this one. So when I'm working and reading, this seems to be more delayed. So like, it's not only latency from me to you, but it's from me to you back to me, and apparently the dock seems to be slightly slower than the dashboard. So like, I think I might actually. Thank you for saying that. I assumed a normal would be reasonable, but 30 seconds would not. Is not in the range of reasonable of what I would have expected. And I'm not streaming at a terribly high bit rate. I'm curious what ultra low latency would do though. I wish it would like what's near real time. Like what? I mean, I could just do the streams and the streams already only in 1080p. So, and I don't think I've got a terribly high bit rate. What's YouTube bit rate streaming max? I think it's pretty big. Okay, variable bit rate. I mean, I'm doing 30, so video bit range. Okay, I'm on the low end of that. I think I've got it set to 3500 right now, which seems to be pretty good. I mean, let me know. If I would have it WebRTC, it's like 5 milliseconds or so. Yeah. That's also a whole other can of worms. Yeah. I've done WebRTC to bring people on as guests. There's a site called video.ninja. And that uses WebRTC. I'm like 95% sure. I mean, it says peer-to-peer, ultra low latency, but it's not actually saying WebRTC. I'm pretty certain this says WebRTC. But the problem is peer-to-peer WebRTC means that I'm giving my connection to everybody. So for you to have a good, like, me to you would be fine. Me to you, me to another person, me to another person. At some point that doesn't scale. So as far as that's concerned, this is kind of what we're stuck with. But honestly, a couple of seconds probably isn't a big deal. No, I mean, honestly, that's the kind of interruption I appreciate. I mean, it is completely off topic. But also 30 seconds? No bueno. I'm streaming again tomorrow. I will try. Should we go for ultra low latency? Do we do that? Should we try it? I also need to, like, my camera's like slowly falling down here. Yeah, I'll have to adjust it later. It's cutting off my head. The arm it's on, I think, just slowly goes down. I mean, when I say slowly, I mean like I haven't touched it for like months. So probably even me just turning on and off is enough to move it down. But trying to use LiveKit for your WebRTC project. It scales with WebRTC Stun. I have not heard of that. Session traversal utilities for NAT. So what additionally is that gaining you? Okay, so ICE is what I was saying before. Straight up connection is a protocol to discover a public address and determining. Got it. So we're basically putting a server in between us, and rather than my computer being the thing that needs to support multiple clients. Too late. 30-second delay. I'm in the rabbit hole. So with Stun, you're putting a server in between us, and now the server is the thing that needs to handle the peer-to-peer. I mean, is that... I guess it's still different because WebRTC is a different type of connection than watching a stream. Honestly, though, like I still don't. If latency is only a couple seconds, I don't think it matters that much. Like that's gonna be long enough. Like that window is gonna be enough for me to like be typing something and just completely miss a chat message. 30 seconds, like that's a big gap. But if it's a difference between like 1 second or 3 seconds, that's gonna be nil as far as I'm concerned, because 1 to 3 seconds might be a time span which within I look at chat. You watched another video with the title Rapier.js. It had nothing to do with Rapier. What's interesting is the Rapier stuff is physics, but then it's like a container and it has all these other things within Rapier. So like I'm doing physics stuff, and like right now I'm like really focusing on the physics part of it, but like it could be doing Rapier things, but I'm gotta do stuff within the physics system too. So like, I don't know. It's really hard to come up with like, and especially now with these streams where it's like I need to determine the topic ahead of time. These past few streams have been real long, which has been fine. I intentionally have been letting them go long, but it's funny because the topics that I'm expecting to do ahead of time end up changing through. I mean, even the stream starts and I go, okay, well, we figured out a thing, and now it's going to completely change what I was expecting to work on. It's a little bit easier when I like do the whole stream and then I know ahead of time like what is going to be contained, or before I put up the video, I have the stream recording, so I know what happened. Yeah, I don't know. What was that? What video was that? I thought I've been pretty good with it, but you know, I'm human, and I also have gotten behind in uploading things. So what actually happened in the video might not always. It's really hard to watch 2-hour video just to get the whole like content to figure out the title. All this is making content is hard. Changing topics like me changing startup ideas. Ugh. Yeah. You know, like ADHD is real. What do I gotta say? I've not been diagnosed, but we've gone through like 4 rabbit holes in the matter of like 5 seconds here. But yes. Can we go for ultra low latency? I mean, we're like totally distracted now, but like ultra low latency. It says ingestion issues on your network will affect viewers more than the setting. Consider decreasing the bitrate to make sure your network. So assuming my network can sustain the stream. Let's see. Stream health. Stream is healthy. Thanks, YouTube. That's not it's not terribly helpful. Can I see what my outgoing bandwidth is right now? I'm gonna look at my router and activity. Upload is what I care about. This among many other things, I've got an Arrow router, the EERO Arrow, and it works well for a router, but there are definitely a bunch of like advanced things that I would love to be able to do that like routers I've had in the past have done, and this is like, it seems to be the type of router that's not intended for like super pro user. I want to get into all the stats and stuff, because like I can only just see like how much I've uploaded today. That's not helpful. I want to know if I'm like saturating my upload. We'll try it. Tomorrow we will try the ultra low latency, and if it doesn't work, I'm gonna complain the whole time and blame you. No, I'm kidding, man. I'm kidding. That would don't stop the style with how I'm doing it. Oh, nice. I'm glad that you appreciate it. So I used to stream on Twitch. I just this week started streaming on YouTube only. So I've officially made the switch. A couple weeks prior, I'd been doing like prep work and some of this to set myself up to a position to where I can make the actual switch. And I think with that switch, what I'm going to plan to do is make this stream a little bit more like be okay with it not being extremely focused, and have it a little bit more behind the scenes and a little bit more like this is a conversation between us and we're exploring things, and I don't want people to feel bad about asking questions and distracting. So if this becomes more of a behind the scenes thing, the live streams will be, I think, a little bit more enjoyable in that respect, where I don't have to feel bad if I don't get a whole ton of stuff done, or feel like I need to like continually try to stay on topic. I think it's going to be it's going to be a very small subset of people that will watch the channel that I think is going to like want to watch the content straight through at 1x speed, which is fine. But I think all of this that I'm doing, I can then I'll have less effort in like editing the videos and getting them uploaded to YouTube, and I can instead put that energy into taking everything that we learned. I mean, this is unrelated. This kind of stuff, taking this that I've learned, and like putting it into like succinct videos. I could do like 5, 10, 15-minute videos. And that might be, you know, that content might have come from 2 or 3 live streams or something. And that is, I think, going to apply to a wider audience and be a little bit easier to digest. Rather than, especially this week, I've had like, this is stream number 3 this week, and they've all been like 3+ hours. So we're gonna try it though. We'll try the ultra low latency. I think we can. I'm streaming in 1080p. I don't have a terribly high bit rate because we're not doing fast. I'm not moving all around. That's been in the same screen for like 10 minutes now. I don't think we need a high bit rate. So I think we can sustain the ultra low latency, and then we're not going to have the 30 odd second delay. I don't think I'm going to saturate my upload speed for that. I hope not. What actually? Can we do keyframe frame rate up to 60? Let's say bitrate streaming 1080p. What upload speed? Required upload speeds are between that and that. Should be fine. at 60 frames per second. So like doubling a bunch of those. Yeah, we should be good. I should be able to switch to ultra low latency and not saturate my my upload. I'm doing this at a time when there's nobody else uploading either, both at the house nor at like neighborhood wide. I wouldn't expect there's too much activity going on. You know, people going to work and everything. So we'll try it. Anyways, destruction complete. Can we get any more of this done? Or are we gonna call it a day? We're ready at like 3.5 hours. That's a pretty long stream. I am clearly getting much more easily distracted, which I think is saying something. We were looking at the API, the rigid bodies, to see if we could apply translations for a specific collider. It doesn't seem like we can. This might end up being something that I just ask in the Discord. Issue when generating colliders. Because if I can get this like adjustment of the colliders working, I think we're gonna be set. Because I think everything else is working. So like if I take out this, doing this, adjusting this collider is not working. But I'm not even adjusting I'm not adjusting any colliders right now. So like this is working. I can probably figure out what the top of that is. So like if we put it over here, and it's actually gonna go opposite. I'm just rendering them this way from the get-go, but new ones will be added to the end and then push the other ones down. So I'm going to fix the top one and then I'll have to apply the kinematic. Let's try that real quick. That's something I want to try. There is the let's just search for Matic. It's kinematic, right? Type equals. I'm on the wrong tab. Bloody hell! I was like, why is kinematic not in the docs? I could have sworn it was. Okay, kinematic. Can. Is it really? Is it really not in there? I'm gonna just have to make sure to open up these docs every time. It's mostly just extending this, as far as I can tell. So if we do. So into this, I gotta remember where I was now. Colliders, center rigid bodies, maybe? Here, kinematic position based. Now in the rigid body, we have type equals fixed. So I'm assuming dynamic is the default. This would be, if we do this to everything else, what is going to happen? I'm going to assume the first letter is not capitalized. Let's take out this console log because it's really chatty. So that seems fine. I think it's fine. So if we the body position must not be altered by the physics engine. That leads me to believe that it shouldn't be moving. Which it's definitely moving. So is my assumption incorrect here? There's literally no mention of it in here. Oh boy, okay. So kinematics example, that is helpful. So the type kinematic, oh, okay. Kinematic position. So if I set the kinematic position, I think those shouldn't move. They're not. So they're fixed unless I adjust the position. So what I can do here is I'll say this. I'm going to just explicitly say that it's dynamic. And that should give me the same feel here. And now if I say, if I adjust the position, where is that? Current set next kinematic rotation and translation. Here we go. So platform, what's platform? Platform is the ref. Where's that ref coming in? Rigid body. Oh, literally, I thought it meant like platform, like the physics platform that you're operating on. No, there's literally a platform in here. It is a box. Okay, so we've got it is adjusting the platform. So we want to do this. That would be on the API in our case. So we can say here, we're going to say api.current.set next kinematic translation. We are going to say x is 0, and we're going to basically move this top piece slowly down. So every frame is going to go down. Let's do a little bit more. So gravity is pushing everything up, and is that just not enough? What? API.current set next kinematic translation. Whoop, whoop. It's on the rigid body. Kinematic position is the type. API. That should only work for the type that is a kinematic position. So I mean, we could even do this, because it's only going to work for that first one. If this did those aren't the right size, are they? Or are they? It's hard to tell. The reason I was looking if it was throwing an error and just like not running that whole block. That's why I was curious. All right, it definitely doesn't seem like it's doing anything right now. See, I would expect this to fire off over and over and over and over. Is it doing anything at all? Let's just put a big number in there and we'll see if it's doing anything at all. So it definitely moves it. But it's sort of like a... We're setting the position. It's not an impulse. We're literally changing the position. So if we're doing this to be... Oh boy. I can't have them like land on top of each other. Let's do this performance.now is the way that it's doing, which is imported from It's not imported? I thought that was a... Is that actually a browser API? I thought that was a... Rapier thing. I guess not. So we're gonna say now, and it will slowly... Well, it should... Whoa. Boy. Okay. Okay. Let's do this really small. There we go. So this, can we see this movement? It's subtle, but I think that's fine. What we'll do is we'll basically just like slowly slide it in, because once they collide, it's fine. If we are applying kinematic translation, it's going to shift all of them for us. So what we can do is slowly set it to be where it's at the top. We pop in new ones above the fold and shift them down, which will push everything else. So if we can get all of our colliders and everything working, I think this is going to be fine. One last thing, I just want to see if we apply a force to something, is it just going to like a wonky mess with the stack? Like, is things going to get real weird here? Whoop, I'm in the wrong one again. Gonna no, not React 3 fiber. I don't need this open anymore, so we'll just do this. There is a like set kinematic velocity. Collision. So there's events, sensors, attractors. We want to like apply a force. There's really... Here. Apply impulse. We can do... Oh, so that was what I was going to do. I want to do like when it's clicked, let's apply an impulse. On collision, enter. On exit. Pointer, default, events, on click. So we can do like on a mesh click. We're going to apply an impulse. So here on click, I don't know what E is actually going to do here. But we've got a ref to the API. So if we do API.current.apply, was it apply impulse or something? Apply impulse. And we're going to apply an impulse horizontally. We're going to just see what it does. And this is going to be basically our check for it's not liking that. Cannot read properties of null, reading 0. So API.current. I mean, I guess, can we just say, can we just say impulse? We're gonna just make a new function that does that, and it's gonna effectively execute it. And we can say then const impulse equals this. Then we have a closure here. Doesn't seem to be doing anything. It is also possible that we've got debug mode on, which is covering things. Let's go ahead and turn that off real quick. We'll try this. If this doesn't work, I think we're basically like at the day. We got layout. We got things laying out nicely. We got the color of the boxes I'm okay with, I guess. We can use some work on getting the collisions and the physics part of it all working though. We also have orbit controls in here. It's possible that those are also taking over. So no orbit controls. Are we even getting clicks? Console.log E. Yeah, it's not even registering a click. Why would that be? Where are you? This mesh. On up to. Also notice the on pointer missed on the canvas element which fires on clicks that haven't hit any meshes. So we have to do it directly on a mesh. And we also have this pointer down, stop propagation. Let's remove that real quick. Yeah, we're not getting any clicks. So like this could be because of the HTML. Oh, there we go. There was a click. Okay, let's do this. Impulse. So what's happening is when I'm clicking, I'm actually hitting that HTML element on top, which is like hiding my click. There we go. So this is kind of what I was worried about. If I apply a big impulse, I think it's actually going to shift the other ones around it if they're touching. which might be kind of frustrating. Apply impulse. Let's say 1,000. This is going to be a big. Gone. Oh, that's hilarious. Before I click this is making me think of the got a table with a tablecloth and a whole setup. Food, glasses, the whole shebang. And you grab that tablecloth and you yank it real hard. But see, stuff still moves a little bit. And that one, yeeted everything. So I don't know if we're going to be able to, just straight up do that. So, this seems to work pretty good. If we can get that gap collider, the collider stuff working. I think we can make that work. That impulse, though, is definitely I mean, if we make it real big, how much are we If I eat it beforehand, it's good. And now if we put one in there in the middle, it does shift the other ones just a smidge. We could potentially remove the friction. And I think that might help us out a little bit here. Mass properties. Is there a friction? Friction. These docs are way better. Where was that friction? I guess there's attractors. We were looking at attractors before. But that damping description is on point. Friction colliders. Friction. If we set friction to 0, set friction. So that would be in the collider itself. If we say friction is a number, no friction. Then we might be golden. Because we want to be able to yeet a part of this and have them not affect the other ones. Oh, that overlap is just oof. There's still a little bit there. Interesting. And it might be something with this. I don't know. We might have to change this out to a custom one anyways. So we'll play around with that. I think this is a good place to stop. Tomorrow we will go ahead and dial in the last of that physics stuff. We were kind of bouncing back and forth a little bit here. We looked at physics things and how it was interacting and to see if we could use physics to basically handle the layout for us. And we are doing 2 colliders. One of the colliders of which is not actually attached. I mean, they're both technically attached to the same WebGL element. But one of them is above the cube, so as to create a gap. And with that in mind, all of our layout should effectively be handled. And then we flipped back to doing the styling. And we got the layout of the text position in there. Seems to be pretty solid right now. I'm okay with it, at least. it's manageable or usable. And then we flip back to physics to hammer out the last bits, because we need to the physics and the positioning, because we need to get that first message to, I can actually point at the top. We need to get the first message right up there, and it actually needs to spawn up in here, like, and then when it comes in, it will go and push all the other ones down, and then this whole thing is going to shift. And eventually the ones at the bottom, we're just going to remove from the state. So anything above 20 or something, we're just going to like nix them. And we will basically be, if the index of that element is 0, we will be using the kinematic position as a way to adjust the position of it. Or we're going to be controlling the position of only one element. And I think that's going to be the key. All the colliders, get everything else to stack. We're controlling the position of one element, the one at the top, and we're just shifting it down. And then when we get a new element in, that changes. And I think that's gonna be fine. At least for now. That'll get us rolling, and we can continue to tweak it. More content, right? And go from there. So tomorrow, fingers crossed, we should be able to, based on the progress we've been making. Hopefully it's not a whole super another long stream, but I think we can knock it out. I think we can get it rolling, and then next week I'll likely go back to a normal stream schedule. We'll just do every Friday, pending holidays, and we'll go from there, and hopefully see some more targeted content that might end up coming after the holidays. We'll see, but at least we should be all set up to operate everything that we had before in Twitch, except do it now for YouTube and all in our WebGL scene. And right now they are separate scenes, so we'll try to stretch goal. Maybe tomorrow we try to put them all in the same scene. Not holding my breath on that one. And there's some refactoring that we want to do too, anyways. In the models, got a bunch of copy and pasted code, which we were expecting to have to refactor, but it didn't make sense at that point. So some of that I might just end up doing off stream. But tomorrow, physics. Try to get the kinematics and those colliders all resizing, the colliders resizing properly, and then the kinematic position set appropriately, so the first message is at the top. That's the goal. Thanks for stopping by, anybody. Long stream. Thanks for anybody watching the replay. Bye. See you tomorrow.